Background noise is not too bad. Okay, guys, so welcome everybody to today's OpenStack online meetup. Today with us is Emily from IBM, and Emily will talk today about ZVM or ZVM, as I learned. There are two ways to pronounce that, which is a mainframe virtualization product that IBM is using in conjunction with OpenStack. A few logistics. The session will take approximately 30 minutes. In case you have any questions, feel free to ask those either through IRC. We are on Freenode, hash OpenStack #community, or via Twitter at OpenStack_OM, or via Google Hangout. And with that said, Emily, the stage is yours.
Thank you. So my name is Emily Hoogenbrook. I'm a software engineer here at IBM. We've been working here for about 8 years now. I work on the ZVM hypervisor, which is our main mainframe hypervisor product. I work out of Endicott, New York, which is a little town about 4 hours outside of New York City, so out in the sticks, as we say. So I'll just get started sharing the presentation here. So I wanted to start first with a little bit of background about ZVM. So we have about a 40-year history with ZVM. If you've seen the IBM mainframe this year, actually just celebrated 50 years. So we've been around almost as long. And when we first started out, we supported a lot of excuse me, IBM operating systems, IBM proprietary operating systems like ZOS, VSE, TPF. But around 2000, someone did a port of Linux to the mainframe and to ZVM, and it's worked out really well for us. It's actually now the main guest operating system that we support, and it's worked out well for our customers. It's brought a lot of new workload and new customers to the mainframe, so we've really appreciated Linux and working with the open source community. So ZVM is part of a two-layer approach to virtualization, along with logical partitioning. So the logical partition really partitions the physical resources of the box. It will divide up memory, it will divide up or share the CPUs, and then ZVM runs within that logical partition and really shares its available resources between its guest virtual machines. So some of the strengths of ZVM, I would say memory over commitment. You know, it's pretty common to see like a 3-to-1 ratio of virtual memory to actual real memory. I/O, especially if you have multiple guests or multiple instances that are running very high rates of I/O, we handle that pretty well. Cryptography, on the mainframe we have special cryptographic offload engines, so that goes really fast. And our ability to run hundreds to thousands of guests instances on a single hypervisor. Linux is a little bit bigger, so we usually tend to be more in the hundreds of instances. But it's very easy for our customers on a single mainframe to get thousands of guests. So some examples of workloads that we run. A lot of the Linux guests are running web servers or databases, DB2, things like that. And our customers tend to be really banks or insurance companies, government agencies, a lot of Fortune 100 companies. So people who are really concerned about security and reliability. And I'll just stop periodically and check and see if there are questions.
So there are no questions so far, so please go on.
Okay. So just to draw a little picture of what ZVM looks like, here you can see we have the logical partition that divides up the memory resources. It has some logical CPUs associated with it. Again, these can be shared or they can be dedicated to that partition. And then our hypervisor runs here, ZVM, and then we run different kinds of guests. So like I said, Linux is the main one we run, either SUSE or Red Hat Linux. We also run ZOS, or we can even run our own operating system second level. And a lot of times customers will run ZOS and ZVM second level in test configurations to try out a new release before they put it into production. So you can see here that we've overcommitted the CPUs. We have 4 virtual CPUs and only 3 real ones. And again, that's common. Usually CPUs are overcommitted by a lot more than that. So that's just a little bit of a picture of how ZVM works. So as we're talking to our customers, I think they have a lot of common challenges that probably a lot of businesses are facing right now. One thing that's kind of unique to ZVM is that since we are 40 years old, we don't have a native GUI interface for setting up and managing instances or applications. And most of our customers tend to write their own. We have some vendor products out there that work with them. But that's always difficult when new customers are coming to the mainframe, or when our customers are training new staff and things like that, not having that nicer interface. Sprawl, I think this is probably true across the entire IT landscape at this point. Our customers are dealing with a lot of virtual machine sprawl, so managing thousands of guests is difficult to do with just little scripts that you've written on your own. Virtual configuration sprawl, I mean, it's difficult to manage all of these different Linuxes when they're all running different levels. They all have slightly different sets of applications, and especially for our customers that tend to be very security conscious, the idea of a level of Linux or an application that hasn't been updated right away, that's a potential security hole. All of our shops are running multiple platforms, so they're running Power, they're running x86 in addition to their mainframes, and we hear from customers all the time that they want solutions that will really manage across all their different platforms. They want a single pane of glass, as they say, that will show them all their different platforms. And finally, one thing that we always struggle with Linux is bringing new applications to the mainframe, to the Z platform. And that's really, there's a team in IBM that works on that. As new applications come out, they do ports of it to the mainframe, but that's a little bit of work, certainly a little bit of test work. So we really like the idea of OpenStack in that it gives us these standardized OpenStack APIs, and then businesses that write new applications to the OpenStack APIs, then this gives us a way to easily port them to the mainframe. So these were the things that we were thinking about. And as we talk to our customers about cloud and about self-service, most of our mainframe customers tend to be really worried about security, and they're also really worried about auditing. And so I was just talking with customers last week, and one of the things that they brought up is that sometimes to create a new virtual machine, it can take 6 weeks. And it's not because it's that difficult to create a virtual machine and install Linux and applications. They can do that in minutes or seconds. But it's really time consuming to go through the whole process of getting approvals. Even a machine that's going to be used for test. If it's at a bank and it might have some sensitive information on it, it has to be tracked really closely. And so that whole process is really time consuming. And they're looking for tools that will help them manage that and help tie that into the creation of machines. This time-consuming process also means that they have a lot of extra virtual machines being left around, and no one really wants to give something up if it's going to take another 6 weeks to create it. So our customers are always struggling with that, and they like the idea of self-service. But it really needs to have the security built in and also some way of auditing and doing chargeback and things like that. So I'll just stop quickly and look for questions. So I see that there's a question, is this hypervisor similar to a Zen VMware or KVM architecture? And so it's a hypervisor like those, but it is entirely built by IBM and maintained by IBM. So we're not built off as a KVM platform or anything like that. We're a totally separate product. So as we were designing this solution with Openstack, some of the things that we thought about was that we already have in ZVM support for XCAT, which is the Extreme Cloud Administration Toolkit. This is another open source product. It's available out on SourceForge if you want to download it. And we had already built that into our product, and it provides these REST API interfaces. So we felt that it was a natural fit to sort of put Openstack on top of that because we already had the REST API interfaces. We also wanted to minimize kind of specialty code in Openstack. We're not yet in the community with this. Obviously, we would like to. We would like to have ZVM be part of Nova and Neutron. But since we're not there yet, we really wanted to make sure that we weren't writing a lot of specialty code in our Openstack driver. We also wanted to build the support into ZVM itself. So we wanted it to be that when you install ZVM, you get the Openstack solution with it, and you didn't have to buy something else and then install it and have to deal with installing RPMs or something like that. So what we've done now is it is part of ZVM, but the supported configuration, you do have to buy the IBM Cloud Manager family of products. And this isn't really something else that you have to install. It's just giving you the IBM support contract, basically. And finally, there was a big corporate directive to support Openstack. And there were a couple reasons for this. I think IBM as a whole is really trying to make our portfolio more uniform. You know, we have these 3 different architectures with x86 and Power and mainframe that we're trying to support. And like we've heard from our customers, we want a single pane of glass. And you know, we like working with the open source community. Like I said, Linux on the mainframe has brought us a lot of new workload and a lot of new customers. And so we've always seen the benefits from working with the open source community. So we really like the idea of working with Openstack. So to get to the big picture of how all of this fits together with ZVM, here I've shown 2 ZVM systems, each running in their own logical partition. And I've shown 2 here. It could be more than 2. It could just be 1, but just for illustrative purposes. And you can see they have some Linux guests running on there. And obviously, I couldn't show hundreds of Linux guests because ran out of room on the slide. But give you an idea, there's some workload running on each of these systems. And on each system, we have what we call a Systems Management API server. And so this is something that we've had in ZVM for a while. It provides a programmatic way for especially our vendors, whether they're internal to IBM or external to other companies. It provides a way for them to talk to ZVM in a programmatic way. And so these system management APIs are how we talk to XCAT. And if you're not familiar with XCAT, it has kind of 2 parts. It has the idea of a hardware control point, this ZHCP, and that needs to run on each system. And then it has a maintenance node. And so this maintenance node only needs to run on one system, and then it talks over SSH to the hardware control points. So it's sort of the brains of the operation, and it decides when a request comes in, which system it needs to go to, you know, which system to create an instance on, and things like that. So that was kind of our existing infrastructure. And then we built our OpenStack infrastructure on top of that. So you can see here each ZVM system now will come with a compute node. And so the compute node is going to have like the Nova driver for ZVM and things like that in it. And that's actually going to run on each ZVM system, but it does talk then via these REST APIs to the XCAT maintenance node. And then on top of that, there's a Cloud Manager with Openstack controller. And so I've shown this in a separate box up here. It could actually be part of one of the compute nodes. You only need one for multiple compute nodes. I have shown it in a separate box because if you do already have IBM Cloud Manager with OpenStack, or CMO for short, then you might have this off on perhaps an x86 system or perhaps a power system. And in that case, if you already have it, you can just plug in your ZVM systems to it, and it will control them. And so in the controller node, we have things like Neutron and Glance and Cinder. There's also a scheduler in here, which is the Nova scheduler with some additions. And so it's this controller that you'd interact with as far as the Cloud Manager user interface. And then that would send requests back down the chain to the compute nodes that talk to XCAT, that then talk to the systems management APIs, and then get things done on the actual system. Currently, we're based on Icehouse, so this support is actually going to come out tomorrow. It was announced just last week. Everything is packaged with ZVM, and like I said, just if you want the IBM service and support, you do have to buy the IBM Cloud Manager products. So I'll just pause and look for questions at this point.
I see no questions, so please feel free to ask, guys. I see that 25 people are with us currently live, so...
Okay, cool. I'll go back to the presentation then. So some of our supported features in Nova, things like your basic instance support, so launching, reboot, resizing, all the things that you would want to do with an instance, taking a snapshot. Also live migration, so you can move a running instance from one ZVM system to another. Full integration with Glance for images, things like that. Our supported features for Neutron, right now we're only supporting layer 2, but we are supporting VLAN networking or flat networking. And in Cinder, we're supporting attach and detach volume. And right now the support, I know there are a variety of IBM storage products that are supported for OpenStack, but right now the ZVM support is only for the IBM StoreWise family for SCSI disk. So the advantages of OpenStack on ZVM. Ease of installation is probably the first one and the most important one for our customers. You don't have to buy a lot of extra products and configure them on top of ZVM. All you really need to know once you do the install is what the disk configuration is for these guests to run the controller and to run the XCAT, things like that. So you have to give them some disk space. And then you have to give them some networking information, so IP address, OSA card address. And then we take care of all of the installation and all of the configuration of those systems management API servers, the Extreme Cloud Administration Toolkit, and the OpenStack compute nodes, and also the controller node if you want that done on ZVM. Because we're owning and configuring the entire stack, we can take advantage of some data sharing, like we can have Nova and Glance share images. We can also use systems and special features. So there are a variety of ways that you could copy an image to a volume in ZVM, but the way that we've chosen, because we're controlling this entire stack, we get to choose, well, okay, we want to use the super fast copy, flash copy. And it does take away a little bit of choice, but we think that it simplifies things, and of course it's pretty fast. So we think that that's a good trade-off. And of course, because we support these OpenStack APIs, it means that if someone writes a new application, then it will work on Z, and we won't have to do a special port of it to the mainframe. So just to talk a little bit more about this Cloud Manager product, Cloud Manager with Openstack. So it's one of a couple IBM Openstack products out there. But this one we're highlighting today because the System Z support is scheduled to release tomorrow. It was just announced last week. This support is really for managing the mainframe from the mainframe, or if you want to manage the mainframe from other platforms like Power, like X. So some of those other platforms that are also supported by Cloud Manager, KVM, Hyper-V, Power VM. So it really lets you get this single pane of glass across all your different platforms, all your different virtualization. The type of Linux images that you manage can be either SLES or RHEL, and those are really the types that are supported on the mainframe, so we cover everything there. And it has some features like a chef-based deployer. We have support for DB2. Like I mentioned, we have the scheduler that does placement of instances and things like that, and that's based on the Nova scheduler, expanded a little bit. And then talking about the self-service portal, and I'll go through some more examples of this in a bit, and this is for billing, but it also includes things like approvals and resource expiration, and these things that really matter to our customers as they're going forward, managing the whole process around creating an instance. And so if we look at the picture of Cloud Manager, and so this is, if we go back to the before, I'm kind of taking the top here, the compute node and the controller node, and looking at them in a little bit more detail. So you can see we have OpenStack Icehouse, and so that's just, you know, the exact Icehouse release taken out with the Nova drivers that it has in it. So that's how you can hook up KVM on Power or on x86. You can hook up Hyper-V. vCenter, of course, you'll have to buy vCenter separately from VMware, but if that's something you already have, you can hook it into the IBM Cloud Manager solution, and it can manage that for you. And then we have our OpenStack drivers that we've written ourselves, like the ZVM driver. Also, Power VC is like this. And so this is where, if you were writing applications on top of OpenStack, this could talk in and talk OpenStack APIs, and then it would run on whichever platform it needed to, whether it's KVM or ZVM, wherever it needs to create a guest or modify one. And then the cloud administrator can also talk to it through a Horizon-like interface. Then we have an infrastructure as a service gateway that goes over to the controller. And so the controller is where you're going to see the user interface for the cloud user. It also provides another set of APIs that IBM has used for some other types of applications that they call the smart cloud applications. So the smart cloud applications kind of extend Cloud Manager with some more functionality. And that's another point where if you had vCenter, you could also hook it into there. So I'll just stop and look for questions at this point.
So we still have no questions, so we can keep going.
Okay. So I looked for some kind of similar products to this, and I found that VMware is also doing an appliance. I think this is currently in beta. It's really targeted to managing VMware. It has support for vSphere and vCenter and NSX, but it's really targeted for x86 only. Red Hat also has a virtual appliance for OpenStack, and again, it's targeted for managing Red Hat on x86 right now. And so this is something that we're hoping going forward, you know, when we take the ZVM driver out to the OpenStack community, we're hoping, you know, then other vendors like Red Hat might pick it up and put it in their solution as well. So to look at Cloud Manager a little bit more and some of these cloud user functions. So a cloud user is someone without administrative authority, just wants the self-service portal, maybe a developer or a tester within an organization. And so we have the idea in Cloud Manager that you organize resources into projects. And so a user can request access to a particular project. A user, of course, can request different kinds of images and set up certain parameters that they might use a lot, like a certain flavor for an image or certain CPU and memory requirements. And then, of course, they have a lot of control over the instances that they have, starting, stopping them, querying them, deleting or cloning them. And so that's the basic kind of self-service portal. And so this is what it would look like to that user. You can see that they get their instance summary on the right-hand side here. And then they have a choice of, they can look at what images or instances they have out there, if they have any requests into the administrator, what projects they're part of, stuff like that. They also get information about how much resources they've used, and so they can track their account and monitor what kind of resource usage they have. And so this, again, is really important to our customers who want to be able to do chargeback within their organizations and say, okay, this particular instance is costing us this much a month, and so that needs to be charged to a particular organization within the company. The cloud administrator, of course, has lots more permissions and lots more stuff that they can do through the Cloud Manager interface. So they can do the cloud configuration. If they have vCenter and want to tie it in here, that they can do that. They can configure networks. They can do anything they want to do with images, creating new ones, even deciding what that cloud user gets to see. If there are just simplified options for images that he wants to present him with. And as far as volumes go, I mean, anything they want to do with volumes, create, delete, attach, detach. A lot of control over project management, so deciding which users get to be in which projects and deciding what their role is going to be within a project. If they're going to own the entire project or just be able to create and delete some instances within it or something like that. And it also has an idea of these expiration policies, which again is really important to our customers because we don't want to have something like an instance that was created 2 years ago for a project that's finished now and is still hanging out and still taking up resource, maybe hasn't been updated with the latest patches yet, so maybe it's a security hole. So incorporating an idea of an expiration policy so that when a project is finished, you can clean up the resources associated with it. Again, the cloud admin handles all of the approvals, can set all of the policies for what kind of approvals are needed for what user actions, and also can see all of the utilization. So whatever the admin needs to do as far as billing and chargeback to the users, they can see that. And they can see any kind of event logs and failures on the instances. And of course, if they know that a particular system is going down for maybe maintenance, then they can initiate some live migrations to get the instances off that system before it goes down for an upgrade. And so again, you can see their panel looks kind of similar to the user panel with an instance summary, but then with a lot more options. This is kind of showing 3 screenshots at a time here. But the idea that you can look at the images or volumes or instances or the reports about utilization and users and things like that. So that's just a quick high-level overview of what you can do with Cloud Manager. So in summary, ZVM is a robust technology. We have a lot of existing customers who have high performance, high security environments. They're really interested in cloud. They like the idea of going forward with cloud, but they're concerned about things like security, things like chargeback. And so we've tried with Cloud Manager with Openstack to address these concerns. And as of tomorrow, the support is going to come with ZVM, be packaged with it, and allow the mainframe to be managed from the mainframe, or to allow the mainframe to be managed from X or P. And this is all part of our cloud journey, our open source community journey at IBM. So, any questions?
Yeah, so thank you very much, Emily. So if you have any questions, I don't see any questions. Everybody's shying away from asking questions today for some reason. Yeah, I would suggest that we stop that session now. For all those who joined us later or who want to share this session with colleagues and friends, the recorded session will be available in a couple of minutes. And Emily, thank you very much for the great presentation, and see you all soon next time.
Thank you.